Good morning, everyone, and welcome to day 3 of AI Sweden's Partner Days. Really good to see you again. And Johanna, who are you?
I'm Johanna Bergman, and I'm head of project portfolio at AI Sweden.
And my name is Ebba Josefson Lindqvist. I'm project manager for the Data Factory. And we will guide you through this last day of the Partner Days of this spring.
Yes.
And yesterday we had some really good presentations and discussions specified on data. Any takeaways from yesterday that you want to share, Johanna?
I think it was really interesting discussions. I really liked the discussion around the legal aspects of federated learning, and that connects to the first theme of today, where we will talk about decentralized AI. So it'll be really interesting to dive into the technical details today, where we talked about the legal aspects yesterday. Yeah, what was your highlight from yesterday?
I also like the insights about really what we can expect from the models and kind of putting the focus there, but also some of the partners shared really good insights on how to get the data AI ready. I think that's a big work that still needs to be done that we can do together. But as you said, a bit more focus on technology today. What's on the agenda?
Yeah, so we will start with talking about decentralized AI with a few presentations. Then we will talk about voice and machine learning for speech to text, and also other aspects related to voice. And then we move on to a block about ethics, where we're listening to Record a Future talking about applied ethics, and then we also have a panel discussing how we can really apply ethics. And we will finish the day with a presentation about the roadmap for applied AI in Sweden as well.
That's true. And then we also do have workshops today that start in the afternoon. And today we have Scale Out that will do a presentation on federated learning. So look into that. You should have the possibility to register in your confirmation email from registering to this event. So look for that. It starts at 1 o'clock. And then tonight we also have at 5 o'clock a live podcast with Brian Reimer from MIT, where we will talk about the research that he's doing on automated systems for vehicles, for example. Excuse me. So you will also find a link for signing up for that podcast in the chat a bit later today. So full program.
Yes.
Should we get started with our first speaker?
I think so. So Ather, please share your or put on your camera, and you can share your screen and also present yourself.
Now we can perfectly see the slides.
But we cannot see you or hear you.
Let's see, there we can see you.
All right, great. So you see the slides and you can see me, I hope.
Yes.
Great. And apparently you can hear me since you responded. All right, good morning, everyone. My name is Ather Gattami. I'm the head of research of decentralized AI at AI Sweden. I'm gonna give you a short presentation telling you about decentralized AI, so why we'd like to do decentralized AI at AI Sweden. We're going to talk about some use cases and give you some examples of the existing technology, but also what we would like to do research-wise, and also how you can work with us. So why decentralized? There are 4 important reasons to do that that I will go through by giving some examples. The first one is privacy, that we probably have heard a lot about in the news for the last couple of years. There are some regional policies that strict transfer of data between different regions and countries. There are communication limitations that prohibits the communication of a lot of data to some centralized entity, and also computational limitations that it might not be possible to do all the computations in terms of training and a machine learning model at a central entity, but we need to distribute it. So the first example is privacy, and literally every mobile application most likely collects data. For instance, all the apps in social media like Facebook or Twitter, etc. And the challenge there is that there is a trade-off between collecting the personal data to give us personalized services, and actually it's good for us because we really get what we want and we do not get the information or a service that we are not considered about. The problem is that this use and access of our personal data might be not that good, in a sense that the companies will have too much information about every individual, and you might not want to have that. And the way to do it is not to share your data to the company. And the question is, what should you share? So that's really the challenge. Beyond the personal privacy, although maybe we individuals would like to allow for our data to be used, for instance, in healthcare purposes, maybe some people would like to donate the data, just like they donate their organs to improve on the healthcare system. There could be some policies between regions that, for instance, a hospital, a specific region may not share sensitive patient data with another hospital in another region. So that is another example where the data transfer is prohibited. We could have communication limitations. For instance, autonomous driving is getting more and more popular. I feel confident that at least by 2030, we might see it in some areas at least. And as you might imagine, we have millions and millions of cars. And in order to improve on the autonomous driving machine learning models, a lot of data need to be communicated from cars to some central entity to train these models. Now, it would be too much data to communicate, so we don't actually have the bandwidth physically. It's a lot of images, there's a lot of video images, so as you imagine, it's really on millisecond levels that you receive new images. And basically, we don't have the bandwidth today in order to share that much information. So again, we would like to communicate more at local levels and build local models and somehow fuse these models to make global models. So this is another example where decentralized AI is the solution. Finally, the fourth motivation is quite similar, but here it's about the computational limitations that we have. So if you think about autonomous driving again, each car collects a lot of information from sensors, images, etc. And all this data, even if we could have a central entity, central computer or computer cluster that can actually receive all this data without the bandwidth limitations, computationally, it would be not possible to train on this humongous amount of data. So from computational perspective, things need to be decentralized also. Now there are some research that got initiated basically around 2016, 2017. Federated Learning that you probably heard about is a start, although it's a very basic model, and we definitely need to have other methods to improve on that. So there are, for instance, methods like clustering, which is, if I want to give you a feeling, is like you want to classify different personalities, different types of users, and you base your algorithms on these clusters. So in that way, you get rid of having too many models for each individual, and at the same time you anonymize the data. There is another trick, which is that you actually mask the data, and that means that you remove some sensitive data from each user in a way so that you cannot identify that person. And this technology relies on similar technologies as to recommendation systems, where every user do not have data about everything personally, but you correlate different users' information, and in that way you can train a good model. So you're actually sacrificing information for privacy. There is some new methods that rely on so-called few shots learning that has been used in, for instance, simulating a moving face or head just based on one single picture. You probably have seen some videos in the media. This could be a way to solve it. For instance, if you have some individuals that are not sensitive about their data, you build some kind of a meta machine learning model. And then when you get some small data from other individuals, you will be able to generate the behavior of that individual. So in that way, you probably do not need the data from everyone, but maybe you can use the data that is available to you from people that donate the data. Finally, this is actually where we at AI Sweden will focus our research efforts, and it is the so-called fully decentralized case. So there is no data exchange at all from a user's perspective. Instead, each user communicates some other kind of information. For instance, communicate their own trained model, even if the model is not of high performance. This is the information that is shared with other users, but it could be also other type of information. And this is where we believe will be the most faced problem in practice. So our goal at the AI Sweden is to take leadership in decentralized AI. And the way we do it is that actually we work with, but also through partners to push the technology forward. Our research group consists both of people at AI Sweden, but also partners. And we work just as one entity, really as one research group that shares information and knowledge. So in that sense, we'll have a unique collection of solution experiences, but also data from various application areas. And I think this would be really unique. And our goal here is that we take the leadership in developing new technologies. And as I mentioned, mostly we will target fully decentralized AI, because this is where you have complete privacy preserving methods. And these are the methods that can most likely also handle the other cases such as computational limitations, communication limitations, and regional policies. So this is what I had to tell you about decentralized AI at AI Sweden.
Thank you so much. And if partners want to engage and join the research group, what can they do?
They just get in touch with me. This is my email address. And of course, they can get in touch with Johanna. And we will be very happy just to discuss with you your problems, what kind of technology you're interested in, and it's very easy. You're welcome to join our research groups and be active. So the only thing we require is that you really have a problem you want to solve and you want to work with us and the other partners. It's very simple.
Yes.
So, Ather, can you give us some examples already of partners who are starting to get engaged in this area?
Yes, for instance, we have Sahlgren, and they have interesting problems that they just started to work on with us, and the format is very simple. They tell us about their problem. We tell them about what kind of research we're doing. We share results, and we work together to help them to solve the problem.
Perfect. And we actually got a question from the audience, and for everyone listening in, you can really use the Q&A tab at the bottom of your screen if you want to ask any questions, and we'll bring them up if we have the possibility. So Ather, the question is, can you elaborate a little bit on the decentralized aspects of the clustering approach you mentioned?
Yes. So the trick here is that you might, for instance, if you take the autonomous driving example, it's typically now hard to share data between countries, although the data belongs to the same company. And what you can do is that you train a model for a certain region. You're free to share within this region. So that's a cluster. And then another region, they train another model, that's a cluster. And then you fuse these two cluster models in order to build a global model that is hopefully better than the local models of the clusters.
Great, thank you so much. And I think that we can move on to the next speaker then. So thank you so much, Ather. We really look forward to the progress of these research experiments, and also generally what's going on in the decentralized program at AI Sweden, because I'm sure there will be quite a lot of projects and ideas coming up from that area.
Thank you. Looking forward to partners working with us.
Thank you so much. And we have our next speaker with us. Perfect. And you're already getting ready, Juan. Great to have you with us. You're from one of our pretty recent partners to join, Scania, and we're really happy to welcome you to AI Sweden.
Thank you.
Good morning, and you will talk a little bit about the work that you do on Edge, which is also, of course, part of the decentralized AI. So why don't you go ahead, and please also present yourself a little bit.
Okay, thank you. I'm Juan Carlos Andresen, a data scientist at Scania, and leading research projects on edge analytics. So today I will present you the research efforts of Scania in this area. So first of all, who are we? So Scania is a manufacturer of premium trucks, buses, and engines that has a market share all around the globe, and within Europe is about 50 to 20%. So it depends on the year you're measuring, but it's oscillating between these two numbers. And we have about 500,000 of connected vehicles globally. And we have relatively high customer satisfaction, and partly it is due to the good preventive maintenance services we offer. From this connected fleet, we can stream and collect different type of data, aggregated operational data, for example, which depending on the service and the data, it is collected in intervals of maybe 1 minute or 1 week or every month. And this data is used for example, root cause analysis, fleet monitoring, preventive maintenance, among other things. And for these services, a combination of off-board and onboard models is used. And in the current situation, most of the maintenance models on production are currently rule-based or physically based. And this usually has a lot of domain knowledge involved. And as the system becomes more and more complex in the truck, so this becomes a bit more difficult to do. It's not that scalable. as well as there is autonomous driving coming. So it is, one could say, at the corner of the street. And this means that no driver will be there to detect deviations from normal operation. So there we need also reliable ways to see anomalies or deviations from normal operation. And here is where the data-driven approach comes, and using the technology developed in machine learning nowadays. So in principle, what we have here is a problem to solve where we have vehicles which are creating data from the sensors, but have an intermittent connectivity. So that is, they might be driving in the middle of the forest. Here in Sweden, we know that there are remote locations where we don't have that good connectivity. So also privacy. So there might be some data in the trucks that we are not allowed to stream or to collect and store locally, centrally. Additionally, so we have the GDPR in Europe, but all around the globe, privacy is becoming more and more important. So we have to take that also into account. Addition to that, we have a large amount of data. So this time series data from the sensors is it's being produced the whole time during the operation of the vehicle. So this is huge amount of data that might not be feasible to stream due to bandwidth, but also due to costs. So one could think directly so that it is actually a school book example for federated learning. So you have all the ingredients that you would expect for such a use case, and it kind of is. So we have here, for example, the vehicle with the sensors and producing a lot of data. We have computational power, so not very high, but enough to maybe train some models. And we have also a communicator, so we have connectivity to the cloud, even though it's intermittent. But we could just send, whenever we're online, send the parameters of the models to the cloud, and in the cloud gather all the models, and then create one global model and then deploy it to the fleet. And this is actually what we have done, but we have other requirements that are there. So I will show you two things that we are now dealing with. And that is, for example, that Scania builds its trucks in a modular fashion. That is that in principle, so one has 1.6 trucks that are identically built in Scania. So to give you a bit more of a background on this, here I show you a graph with where in the x-axis you have the customization of the product. So you have low to high, and in the y-axis you have the volume of the production. So from low to high. So if you would like to have a high customization for the for your clients, or to be able to adapt to their requirements, you will have many different products, and this will in turn be difficult to make a large volume of these very different products, because you have to do it in, each product will have other requirements for the production. On the other side, if you want to have a high volume, you probably will have a low customization. So you will have a few common parts that where you can build your products, but your palette of different products will be not that high. But there's a way around this, and this is to build your products in modules. That is, these modules will be the common parts. So we will have just a few common parts, the modules, but these modules will be built in different ways, or put in together in different ways, such that you can build many different products. So you will have a high customization. You can think about this like Lego stones. So where you have a finite amount of Legos with different shapes, but you can build almost infinite amount of things with these Lego stones. And this is the way Scania builds its trucks. So this is an additional requirement. And of course, even though the product would be identical, you will have a different type of driving. For example, the usages. So you will also use the product for different cases, or long haulage, or city deliveries. So these are additional constraints to the ones we saw before. And this is why now our current research efforts is towards federated modular learning for onboard anomaly detection. So this is that we are trying to find ways to, for example, find the largest cohorts of vehicles where the federation work. This using all this data that we stream, so we have offboard that we talked before, but also in combination with the onboard data, with the sensor data that we have in the truck. So we want to find a way to integrate this modular way of building the trucks into the federated learning protocol and models. Additional to that, there is so the different trucks do not necessarily come from an IID. So so we also are trying to find best ways to train this in a federated fashion. And with this, so we, as mentioned, so we have joined AS Sweden recently, in the last 2 months. And we think this is a very good platform for sharing knowledge between partners, because we know that these big questions that we cannot solve this by ourselves. So we need to be able to have a community, and this platform actually enables us to come into a dialogue quite easily. And also the infrastructure from Edge Lab. So we will be able to test our findings in a quite fast way and fast iterations. For example, we already are in talking to Scale Out, so we're very happy to get to know more about FEDEN and maybe use it in our future projects. So we are looking forward for new collaborations and future common projects from other partners from AS Sweden. So, and with this, I thank you for your time.
Thank you so much, Juan Carlos. Really good to hear how you are working on Edge, and especially how you want to meet other partners also, potentially in the Edge Lab at the AS Sweden, but really good to hear that this is an area of interest for you and that you want to collaborate on getting this forward and move Sweden ahead in this area. So yes. Thank you so much, and we look forward to seeing you.
Thank you.
And that brings us also into the next presentation, also on federated learning. And we have with us both Mina Alibeigi from Zenseact, and then we have Sheetal Reddy from AI Sweden. And you guys have also been working in the federated learning setting. So we look forward to hearing what you've been working on together.
Yes. Yeah, maybe Sheetal, can you please share the screen?
And we can mention that if you want to ask some questions for the attendees, you can use the Q&A or the chat functions, and also see some of the responses there from speakers. So Sheetal, we can see your screen, just waiting for you to have the presentation mode, and there it seems to work fine.
Yes.
So thank you so much. Go ahead.
Hi everyone, my name is Mina Alibeigi, and I'm an AI researcher, and I work with new technologies and collaborations at Zenseact. And today, Sheetal and I are going to show you an Edge Lab demo on federated object detection model using Baltic Seabird dataset. So let's get started, and maybe next slide. Yeah. As you might know, actually, our purpose at Zenseact is actually to make safe and intelligent mobility real for everyone, everywhere. So, and to achieve our purpose, we need to collect a massive amount of data every day by our data collection cars driving Volvo. Because we want to actually ensure continuous development of a world-class AD software. However, as was mentioned earlier presentations, data collection and data transfer are not straightforward nowadays because of the emerging data sharing policies now and then. So, for instance, we have this challenge as Zenseact that we cannot actually transfer the collected data in China outside of China, and we cannot move actually the collected data from Europe to China either due to GDPR compliance. So then the question is how we can train Zenseact, previous slide still, how we can train Zenseact software still on the collected data from all over the world, considering that we want to comply with all the legal legislations. So next, please. So actually one solution to that is federated machine learning, which seems to be a good fit to solve this mentioned problem. Federated machine learning is an emerging technique that trains an algorithm across multiple decentralized edge devices or data centers. In this technique, clients, in our case, it will be like data centers in China and Europe, collaboratively train a common model with orchestration of a central server while holding their actual data locally. So in this case, clients are only shared their learnings or the model updates from with each other from their actual data. So in a sense, no personal data is being shared, which can actually address data privacy concerns in GDPR, for instance. And beside that, actually this technology is get us rid of like the need to move large amounts of data around, which can save a lot of bandwidth and also storage, while we can still utilize the learnings from such data in a successful manner. And also was mentioned also briefly, it opens numerous opportunities to shorten the development loop and improvement of autonomous vehicles for us, because we can then utilize the data which is available on a large fleet of production vehicles, which is also a great opportunity for Zenseact. So next slide, please. So to learn more about the potentials of this amazing technology and the steps ahead to make it real to solve the mentioned challenges and also gain the benefits that was mentioned, we participated in Federated Machine Learning Testbed project funded with Vinnova, together with other partners, and we introduced this POC study called Hello China, which kind of reflect the challenge that I briefly mentioned. And in this POC, actually, we wanted to learn that how federated learning can be used in real mode cross-silo setting to develop machine learning solutions on data that cannot be shared openly between data centers due to the legal legislation. Also, we wanted to see if what is the real impact of federated learning versus centralized learning, if we can get the same results or not. And also, what is the impact of the number of client nodes, for instance, or other components, and also the distribution of the data on the performance of the federated model. So, next, please. So to answer all these questions, in Hello China podcast study, we used the Baltic Seabird dataset, which was donated to AI Sweden by SLU. And to appreciate actually the contribution of pairs in this project, we also called the project FedBird as well. So FedBird is a cross-silo federated learning object detection solution, which actually runs on edge devices available at Edge Lab at AI Sweden. So it's a great example to get us started with federated learning in a real setup and see how it works, and also try out new ideas on top of it. And different partners, including AI Sweden, Zenseact, CAMCOM, Scale Out, and Örebro University, have contributed or provided support in this project, which was appreciated a lot. And in the following, we will see more details actually about the project. Okay, the data set that we used in this project was a real world challenging data set with highly imbalanced classes without having the privacy restrictions, at least yet, which is a big relief for us. So the data set is actually consists of 2,000 hours of video footage of the guillemots on 2 different ledges in Gotland Island. And researchers from SLU and AI Sweden have manually actually annotated these images, and there are 1,800 frames annotated from this video material. And the annotations actually provide the bounding boxes of the birds, which are present on the ledge, and classify them into 3 classes: adult bird, chicks, or birds. Or eggs, sorry. As said, the Seabird dataset comes from 2 different CCTV cameras pertaining to different ledges on the island. One of them is called Farallon 3 and the other is called Roast 3. And in our Federated Learning setup, these ledges are considered as individual data centers, or actually clients that have access to the data. And each CCTV camera is like allotted one edge device, like a Xavier, for processing both the data stream coming from it, but also is responsible for training a local object detection model using the provided bounding boxes from some of these frames of this data stream. And then when the models are trained, then these local models are trained, then they will be sent to another central server at Edge Lab for aggregating the learnings. Which we will see a demo of it soon. So next, please. Yeah, and in the FedBird project, we actually used a modular and open source Federated Learning framework called the FedN, which is developed and also maintained by Scale-out Systems to communicate between the clients and also the central server. And in a FedN network, actually, there are 3 main components, as you can see here: reducers, 1 or more combiners, and also a number of clients. And actually, the combiner network is one that forms the backbone of the federated machine learning orchestration mechanism, while the reducer is actually provides the discovery service where the clients are and how to reach them, and also it provides control to coordinate the trainings over the combiner network. To be more specific, actually, the clients are data nodes that have actually access to the actual data, and their role is to train local the model on their local data and also evaluate models on that data as well. And the orchestrator or combiners get these models from different clients and then combine them into a single model. And then these models are then in turn forwarded to the reducer. A reducer, when gets all these models from different combiners, just combine them into one single global model. Next, please. And for the project, we actually used a single shot object detection model called the Yellow Virgin 3 Tiny as the baseline. This model actually predicts the location of the birds in a frame together with their type as well. And we chosen this model because it actually supports relatively small available data set that we had. And also it supports a small number of classes and facilitates fast training on edge devices like Xavier processors as well. And we used TensorFlow framework and Keras to implement the model and evaluated the performance using mean average precision, actually, which is a popular metric for object detection models evaluation. And since the dataset was highly imbalanced, we also used some augmentation techniques to improve the performance of the model. The code base for the Federated project is actually available at AI.c GitHub repository. So you can build on more compelling use cases and add to that. And documentation and Ansible playbooks will also be soon available. So I think now it's time to hand over to Sheetal to show us a very cool live demo of the Federated deployed at the lab.
Yes, yes. Thank you so much, Mina. So before going to the demo, I would like to introduce myself. My name is Sheetal Reddy. I work as a data scientist at AI Sweden as part of the applied AI team. Currently, I'm working on the decentralized AI research that Ather has mentioned. Yeah. So before going to the demo, just want to show you the network topology of the setup that we have deployed at Edge Lab. So we have two Xavier nodes acting as client nodes. So all our data is present on these two Xavier nodes. And we have a combiner which combines both of the local models coming from these nodes. And it is sent to the reducer. And the models are also stored in a database in MongoDB. So we have three nodes which simulating reducer, combiner, and database. And we are using the Fredin framework provided by Scaleout for this. And the models that we have developed are in TensorFlow Keras. And our, just want to mention that our whole setup is deployed at the Edge Lab currently. So when I'm demoing something now, I would be using the clients and the infrastructure as part of the Edge Lab at AI Sweden. So I would like to stop sharing the slides now. So in the best interest of time, I have already deployed the reducer combiner setup in the Edge Lab. So once we deploy the reducer combiner setup in the Edge Lab, we could get access to a dashboard like this provided by Fedin, from where we could interact with the training jobs. So if we go to the network here, so here we can view the information about the setup and the clients itself. So here we see that the active clients that we have are 0 because I haven't started any clients yet. So let's do that first. So now I am opening the terminal screen. I hope everyone can see my terminal screen. Yeah, and now here, let me connect to the clients first through SSH. So now I am inside my clients here. So I've connected to them through SSH. Now what I would do is I would connect these clients to my combiner. Perfect. So now we get a feedback, a message saying that my clients are connected and they're waiting for an assignment. So let's see, go back to the dashboard and see if it is reflected here in the dashboard. So now we see that the active clients that we have that are connected to the combiner are 2. So these 2 are the Xavier nodes that are deployed at the Edge Lab. So now how do we start running our training jobs? So Fedin, this dashboard becomes really handy for us to start the jobs through the browser sessions. So once we connect our clients to the combiner setup, we go back to the status and see that the reducer is idle. That means it is not participating in any jobs yet. So let's quickly start some jobs and see how it works. So initially we have uploaded, we are supposed to upload a compute package which contains all the code the clients are supposed to run. So we do this, we upload this to the reducer, and then the reducer sends these compute packages to the clients. We do this to ensure concurrency between the clients so that they have to run the same model, right? So to ensure that when so now, because we are using Keras, we could toggle between Keras and PyTorch, but because I've already given a few rounds, run a few rounds already, so it's already set as Keras. We can also use PyTorch models. Fedon also supports them. And now let's say I want to run 5 rounds of federated learning training. So what does a round mean? In federated learning, one round means that the server is sending the global model to the clients, and the clients are running on top of their uh, uh, data. They are taking this global model, running training on top of this global model with the local data, and then these local models are sent back to the combiner. So, and then to the reducer. So this is one round of federated learning training. So now we are setting up, we are setting a job for 5 rounds of federated learning training. And here there's something called timeout. So what a timeout means is, especially in our case where 90% of the data exists in one client and 10% of the data exists in another client, it is so that means that one of the client will finish the job very fast and then sends the local model to the combiner, and the combiner has to wait for the other client to send its model. And we mentioned the timeout that we mentioned here is the time the combiner waits for all the clients to send their models. So because our client, the second client, has a lot of data, it takes a lot of time to train. We mention it as like 600 seconds. And then we say, okay, the combiner has to wait 600 seconds for all the clients to send the local models to it. So now we say that, okay, we need validation as well. And then we submit the job. And once we submit the job, we could see that in the clients, our training starts. So it will take some time for these clients to train, but they will train. And then what we could do is we could go back to the dashboard and see what all metrics we can track. I've already started one training last night. So we could just see what all we could track here. So let's say we could track training loss. We see that the training loss is actually going down. That means federatedly, when we're training an object detection model, it is learning something. The loss is going down. And it's the same case with the test loss as well. Let's see the mean average precision values here. So if we see the mean average precision values here, we see that they initially it's 0, and then the mean average precision is increasing. But here we can also see that there is a good amount of difference between the mean average precision values for the client which has a lot of data and for the client which has less data. And there is also a table view where we can track what is the loss and for the training, testing, and also the evaluation metrics that we code as part of our model. So in the mean average precision, these are the mean metrics. So it averages the mean average precision values of both the clients. And now we see, and here we see that the client is spending 99.7% of its time in training the model, and very few percentage of its time in loading the model and also downloading the model. So this is the behavior that we generally expect in federated learning. The clients have to be engaged in training the models for most of the time. So if we go into the network tab, we see that we see the round times of the combiner and the reducer. Here we see that the combiner and reducer round times are a bit fluctuating when you train your model. So this is one insight that we got, but initially we didn't know why this is happening. And then we realized that it is because of the validation that we are doing. So this dashboard comes really handy to handle and understand and gain such insights. So here we see that the combiner is spending most of the time waiting for the updates from the client and is spending very few 0.00868% of its time in aggregating the models. So this is happening because the client is taking a lot of time in training. So, and we also have some statistics about the CPU percentage and the memory that we are using as part of the combiner and reducers here. Right now, because now the training is going on, you can see that in the terminal, one of the clients has already finished the training and the other client is still working on the training. So let's download one of the models and see and visualize how it is working. So here in the mini IO, you could download any model you want. Let's say I download this model, and we could use this model to visualize the results on videos or the test data. So I have done it for you already here. I have used one of the models and then visualize the results, the object detection results here. So the object detection, if you see the object detection results here, it works well, but it is not perfect as of now. Uh, Part of it also comes from the fact that we are using tiny YOLO and not a full version of YOLO, so that we could train such models on resource constrained devices like in NVIDIA Xavier's. So, and I would, so giving some quantitative results. So the experiments that we have done have shown that we have almost in a centralized setting where we have 1,620 training samples and 270 testing samples, we have reached a map of around 34.8 while training for 25 epochs. And in a federated learning setting where we have 1,491 in one client and to 129 in the other client, we reached a map of around 28 when we run for 25 federated learning rounds. And this value goes up as 31 to 32 when we added more rounds. But I thought this is a fair comparison to run it for 25 rounds and see how it works. And one thing that we have realized is that in the federated learning setting, the traditional federated learning setting is where the clients run for one epoch and then we send the local models to the combiner. Uh, Here, because one of the clients have a lot of data in our case, we wanted to run it for a batch-wise training. Basically, both the clients running for the same number of batches, and then we run for 10 batches, and then we send the model back. So in that case, we get better results than running each client for one epoch and then sending back the model. So we are working in this line now to understand the minimum number of batches that we have to train and gaining more insights here. So yeah, talking about the opportunities of using Fedin or using federated learning, it's countless. You could use in healthcare where you have a lot of silos of data. And you could use it for banks, where you can train a single model, credit risk model, and then you can train better personalized models with using the insights from the global model. And for us, federated learning and the FEDEN, with the FEDEN framework, with the dashboard, came in very handy. And that's the reason we are open sourcing the code and everything of this project, so that the partners could come in and play with it and learn more, gain more insights from the project itself. So with this, I would like to end my talk. Thank you so much. And if you have any questions, please email to the above, to the scene email IDs, and we will get back to you. Thank you so much.
Thank you so much, Sheetal and Mina. Really interesting to see also live results. I think that is really brave to show a live demo at a presentation, but I really like that. And we need to move on to the next topic, actually. And so this was decentralized AI, one of AI Sweden's focus areas. And now we move on to language technology, which is another, and we have mainly focused on text so far and Swedish text models, but today we will listen to two interesting presentations focusing on speech. And we start with a presentation from Christopher Rashammar at 10:50. So please, Christopher, you can introduce yourself and share your screen.
Yes, hello everyone. I will try to share my screen. Can you see this?
Yes, perfectly.
Excellent. So, identifying emergency calls at sea for Sjöfartsverket, or the Swedish Maritime Administration. So, hello everyone. My name is Christopher. I work at a company called 1050. I like machine learning, data science, and chocolate. And now we know each other. So I'm going to present a project today that is actually a joint project between three companies. 1050, which is my company, and we build tailored AI solutions. And we have Sjöfartsverket, and they are on top of all things related to sea traffic in Sweden. And we have Maranix, who are experts at digitalization in the maritime industry. So what are we trying to solve, actually? Let me introduce Tobias Nikander. This is him. He works at JRCC. It's the Joint Rescue Coordination Center, or Sjö- och flygräddningscentralen in Göteborg. And it's a rescue center that coordinates all rescue missions for sea and air traffic all around Sweden. So all maritime traffic can communicate on an open radio channel, channel 16. And around the coast of Sweden, there are around 40 radio receivers constantly tuning into this channel and relaying this data to GRCC, where an operator listens for distress calls, such as Mayday, but also other contact attempts. And for each incoming message, the operator decides what needs to be done. Most often, nothing needs to be done. It's just regular communication between ships. But every now and then, there is something that needs to be handled. However, there are many receivers, and there cannot be one operator per receiver. So each operator needs to listen to many receivers at the same time. And most of the time, this works out well. Sometimes, however, different receivers receive different transmissions or messages at the same time. And then it's impossible for the operator to hear anything of it. Or there might come an important message while the operator is on the phone handling something else. So there is a worry that the operators might miss important information. So Tobias had an idea. Can we develop a computer system that assists the operator? It could operate around the clock without getting tired, and it could listen to all receivers simultaneously. This was actually quite a few years ago that Tobias had this bright idea, and then language technology wasn't mature enough. It couldn't be done. But now, these last few years, there has been a tremendous progress. So then this project was initiated. So the goals of this project is to make a proof of concept system that listens to all radio receivers around the clock in almost real time. And we listen for distress calls and contact attempts. And if the system can detect this, it will notify a human operator for further action. And all messages are recorded. So if the operator wants, they can listen to the play back the audio again and again. And since this is international sea traffic, we can receive messages in many languages. Of course, Swedish and English, but we have Norwegian, Danish, Finnish, German, and also Russian. So the system will eventually need to understand all of these languages as well. And probably it will make mistakes in the beginning. So it is important that it gets better from operator feedback. And in the future, we can provide even more information to the operator. Perhaps we can identify the ship's position or the vessel type and the crew size, etc. And if the message is in a foreign language, we can translate it. And we can integrate with all kinds of systems that can be of assistance to the operator. So here is an overview of the system. So we have these radio receivers all around Sweden, and they constantly send information or audio streams to Sjöfartsverket, which sends it to 1050. And here we will have an AI system that will analyze the audio and try to identify important messages. And if so, we relay these messages to Meranics. And they have built a graphical user interface that the operator at JRCC can use and be instantly notified when an important message arrives. And it's important to notice we're not building a PowerPoint demo here. We're building a real system that will be used this summer. And in machine learning projects, it's easy to focus on the machine learning part, but it's never just about the machine learning. It's about the people. We would never be able to do this without so many talented people. For example, Tobias. We could never have done this without him. And we could never have done this without the data. And it has actually been quite complicated to get hold of this data in real time. And we need quite a bit of infrastructure and engineering to make this work. So we have the design, let's do it. So for this project, we're using automatic speech recognition, or speech to text, as it's also called. And I mean, how hard can it be? When Tobias first had his idea, this was an immature technology. But these days, you can speak to Siri, Alexa, Google Assistant, all kinds of apps on your phone. And speech recognition is quite good, right? Well, it depends. So first, we need to take a step back and discuss how do you train a machine learning model in general. you typically start with a neural network, a big one with many layers. This is called deep learning. And the neural network, it can take input data over here, and it does magic things, and then it outputs something you want. But the network cannot do anything yet, so we need to train it on our data. So we do this by feeding the network both the audio files and the correct result, what we expect. And we need many, many such examples. And then the network magically adjusts so that it eventually will produce this output, hopefully. And this is called supervised learning. And finally, we can test it by just give it the input and see if it produces the correct output. Okay, so the good news is this is standard machine learning. We know how to do this. Doing it for audio is slightly more complicated, but as I mentioned, there has been good progress these last few years, and there is much information available. However, the bad news, this is expensive. It takes a lot of time and resources to pull this off. It takes a lot of compute power, and it also takes a lot of time because you need this transcription data. You need the data both in text form, in audio form and in text form, and someone must produce that. But the good news is someone already did this, and we can reuse their model. The bad news is these existing models do not work for us. We have noisy data, very noisy data. There are very weak radio transmitters and receivers, and there's a lot of static noise. Sometimes you can't even make out what people are saying in the audio clips. And we have a very specific language for maritime traffic. So the existing models, they try to make sense of the audio by comparing it with how text normally look. And this is just a short example. This is what a message can look like. And this is what a pre-trained model makes of it. It's just random words. It doesn't work. But the good news is someone invented transfer learning. That means that we can start with an existing model, and then we can train it some more on our specific data. The bad news is we don't have very much data. Actually, we have lots and lots of data. We have many audio files, but we don't have many transcriptions. It's very hard to do these transcriptions. But Sjöfartsverket is working around the clock now, providing this. But the good news is someone invented self-supervised learning. That means that we can train on a lot of data without the transcription, and then train some more on just a few audio files with transcriptions. So if we put this together, we can use a pre-trained model. We train it on some more of our domain-specific unlabeled data. That is, we don't have the corresponding text. And then we fine-tune it on a smaller amount of labeled data. And then we profit. So are we done? Well, there are still a few challenges. Did I mention that the data is noisy? It's actually a huge problem, and it creates problems in all parts of the system. And we need more transcribed data. And we also need something called a language model, which knows how speech in this domain, maritime speech, sounds like. And we need to support several languages, and it's a challenge doing that at the same time. And also we have very few positive examples. of distress calls. And I mean positive examples in the same sense that you can get a positive corona result. So we need real distress calls to verify that the system actually works. And also, it's quite slow working with audio data, so there are some challenges. So what is the current status of the project? We're working towards a beta, and it will be evaluated live this summer by Tobias and his friends. And the plumbing is done. Data can flow from radio receivers all the way to GRCC. And we have transcription of data in progress, and we have model training in progress, and it looks quite good. And we need to say a big thank you to AI Sweden for providing compute resources, because as I mentioned, it's really compute expensive doing this. And that is it. Thank you very much.
Thank you so much, Christopher. Really good to hear you explain how this works and what interesting topics you really are working on and helping Sjöfartsverket with that at this moment. So thank you so much for your presentation. Great to have you here. Now we'll move on to the next part of today,
Yes.
ethics. So I will actually leave a little bit and have another colleague, Karin, come in. So see you in a bit.
Yes, and welcome, Karin.
Thank you.
So please introduce yourself and also the topic.
Yes, so my name is Karin Weita Engström, and I'm the project manager of our very newly launched AI Ethics Lab here at AI Sweden. And I will be with you for the next 30 minutes or so, and we'll start off with a presentation on AI ethics in practice together with Johan Larsson-Hörkén and Fredrik Möller at Recorded Future. So please join us and present yourselves and share your screens.
Hello, thank you very much for having us. I'm Johan, and together with me I have Fredrik, and we both work as software engineers at Recorded Future, with focus on an interest in AI and machine learning. Can you see my screen with a big slide saying AI, ethical AI in practice?
Yep, seems fine.
Perfect. So to start with, Recorded Future is a threat intelligence company or cybersecurity company focused in threat intelligence. We collect and structure data from the internet and provide it as finished intelligence to our clients. We also perform various threat and risk analysis on them for various contexts. But today we will not talk specifically about what Recorded Future does, but we will talk about ethical AI in practice. And we want to talk about this since we found the need for it, basically. A lot of the discussion about ethics and in AI currently is on a higher level. It's on how do we raise awareness? How do we create a diverse workforce? How do we handle the legislations about this? But it's very hard to find people who actually talk about, okay, but what should we actually do? I am a white young man active in AI, so I'm not diverse, but I'm sitting here with my Keras models and my PyTorch models and my Pandas data sets. What should I actually practically do to get more ethical? So our approach to this was to create an ethical AI checklist, which would be some kind of approach to try to democratize the way of being ethical in AI. Some kind of guidelines and some kind of framework to keep in mind when you're developing your project or developing your model. And we want to continue to work on this and develop this continuously. But for a first example, Fredrik will talk about how we use this in Recorded Future.
Yes, quick thing. It seems like I'm not allowed to start my video. If you could fix that. But back to the presentation. Why is this important for Recorded Future? The issue is that we regularly face face the issue of spurious correlations within our datasets. For example, a few years ago, our terror event extractors suddenly started to activate on almost every Christmas market around Europe. But we managed to track down this issue to parts of our models being trained with datasets that contained large amounts of positive samples with content regarding Christmas markets, and thus had overfitted against this specific feature, all because we had this hidden overrepresentation in our data. We also have the aspect of accountability towards our colleagues. My team and I have coworkers that are not directly involved in the development of AI systems, but could be faced with questions and scrutiny regarding our system's ethicality. Therefore, my team and I need to be accountable for our systems. Best case scenario is that this sort of situation never arises, but the bare minimum is that we are able to actually describe our model's behavior. And in the same sort of fashion, Recorded Future has an obligation to provide our customers with as fair and ethical information as possible. And if we fail in this regard, our customers would be making decisions based on the information supplied by us that would be ethically compromised, and they would not be aware. And this would be a breach of trust between us and our customers. And if we go to the next slide, Johan. So yes, how did we actually apply this checklist in our company? So what we did was that we applied the checklist to an ongoing project as a pilot to see how it would influence our work and what the outcomes would be. We don't want to wait until a new project started to test it out. This was our first time doing it. We did not really know what to expect, but we thought it's better to do actively work with this than just doing what we usually do. So we used this checklist that Johan presented, such that each project member were responsible for the parts of the checklist that matched their tasks in the project. And we finished the project with an ethical evaluation, which had participants that had the following roles in the project. So we included developers, definition owners, annotators, the person who ordered the features to be included in our model. We also included an external project which had nothing to do with the original project, but we needed a new perspective. And we also had one person acting as an ethics officer, which would be driving the meeting. And so our takeaways from this, does it work? Yes, we absolutely felt that we managed to develop a more ethically sound model by actively working with the ethical aspects. What we discovered or felt as well was that ethicality can't be an afterthought. It's an active process from the start to the finish. And our tip is don't do what we did in our pilot case. We also feel that it's better to have regular meetings from your project start to the end of your project with ethical reviews. And we think that this approach would have a much larger impact to the process and result than one large meeting at the end, as we did. And the most important takeaway is the perspectives are keys. Use different perspectives. The whole point is to incorporate knowledge and thoughts from a wide range of backgrounds. Ask co-workers from different departments to help, and to get this perspective that you need to make a more ethically sound model, dare to step outside of your regular bubble. And now Johan will take the rest.
Yes, but we don't want to end up in a case where we have just created yet another checklist. There are so many checklists flying around out there. And every company might have their own interpretation of that, and that's fine. But what we want to achieve is to align this with the existing mainstream checklist out there, such as EU's guidelines for trustworthy AI. And we want to democratize this and allow the community to help. So we have open sourced this, and we don't see this as a finished checklist. This is an ongoing evolution of how we can evolve and find a common way to have a best practice on which steps you should take as an individual when developing a ethical AI model. So we want to keep this short and lightweight, so never to go over, let's say, 10 points or something like that. But we want to have it as flexible still, so that it could be applied both by the home hacker sitting on his in his basement and hacking out the new futures, new take over the world machine learning models, and to researchers and to both small and large organizations. But this is a very ambitious goal, and this is where we need the community's help. But we also think that by following this checklist, it also follows some of the best practices of developing ML models. You want to evaluate your data set, you want to continuously measure performance, you want to discuss the models with your peers, because that's how you achieve better performance in general. But that is all that we had. So please check out the ethical AI checklist on this GitHub link. If you search in GitHub for ethical AI checklist, you should be able to find it. And if you have any questions, we would be happy to take them now. Otherwise, please reach out to us on these email addresses or in the chat later. Thank you very much.
Thank you so much, both Johan and Fredrik. That's really great, I think, to see how you're working with AI ethics in practice as developers, given that it's a very interesting and broad topic and many people are talking about it. We have a wide range of guidelines and checklists and regulations and policy around this. But it's really great to see how you're working with it at Recorded Future. So we will now have a panel discussion together with also two other partners. So we have Don Lekkinen at Microsoft and Evelyn Antla at Peltarion. So please join me. Hi, welcome both of you.
Hello.
Hello, thank you.
Since you haven't been with us during the day, maybe we should start with a quick presentation. Evelyn, if you would like to go first. Evelyn, I think that maybe you're muted.
Sorry. Yes.
Go ahead.
Yeah, so I work at Peltarion, which is a Swedish AI company. And with our platform, we make it easier for companies across all sectors to build AI systems without having its own infrastructure or AI experts. And I head up the Public Affairs, Legal and Ethics department.
Great, welcome. Thank you for joining us. Daniel?
Yes, so my name is Daniel Ackenheim. I work as something called the National Technology Officer for Microsoft. So I'm responsible for policy and technical strategy at Microsoft. And I also do a couple of other things which is related to, I'm co-founder of Add AI, which is kind of a think tank on artificial intelligence. And I also work in something called the Digitaliseringsrådet, which is the kind of the government's think tank to some extent on what should we invest in Sweden to make Sweden basically a stronger digital nation.
Great. It's fantastic to have all three of you with us for this discussion. So we're hoping to talk about AI ethics in practice during the next 20 minutes or so. But I believe we should just take, and I think that your presentation at Recorded Future was a great stepping stone for this. But just to take a slight step back and look at the policy landscape, we all know that AI, there were AI regulation suggestions coming out of the European Union as early as last week. So I just wanted to ask you, Evelyn, if you could just give us a quick recap of what was going on there, and we could take the conversation further on from there.
Yeah, so as you mentioned, last week or a few weeks ago, the European Commission announced its proposal for a new AI regulation. And it's a result of several years of preparatory work. You may recall that last year we had the white paper, basically setting out a legal framework. And this is a very ambitious project that the Commission is launching. It's the most detailed AI regulation in the world, and many people argue that this is basically a new GDPR, but for AI. And the proposal includes a lot of obligations impacting businesses across many, if not all, sectors of the economy. In short, it includes prohibitions on a number of use cases that are considered too dangerous or too dangerous to people's safety and fundamental rights, basically, like mass surveillance and social credit scoring. They also define high-risk AI and say that high-risk AI use cases will be subject to specific regulatory requirements, both before and after launching the product on the market. And there are also transparency requirements for certain AI use cases. The sanctions are similar to what we see for GDPR. But on the other hand, the proposal also includes provisions intended to promote the development, uptake, and trust of AI technology in the EU. So what happens next? Well, this proposal now goes to the European Parliament and Council for further debate and consideration. It's expected to generate a lot of discussions in light of GDPR, but also in light of this heavy proposal. I personally think that we will see substantial amendments to it, but we'll see. But what is really good with this is that now we can really talk about ethics and legal requirements around AI and include more people around it. So I really appreciate this broader debate around this area.
Thank you, Mina, for giving both a recap and your perspective on it. Looking more broadly at the various amounts of policies and regulations and guidelines and checklists around AI ethics, Daniel, would you mind sharing a bit about how this affects and your work at Microsoft?
Yeah.
When you look at AI ethics?
So, well, when it comes to the question, how does a company deal with AI and the topic of ethics, I think this is something for many companies it's rather new, actually. I think if we go back and think about ethics in general from technology perspective, it's quite rare that that has been discussed as much as when we're talking about AI, and that's because AI is powerful, of course. So I think people have realized in a couple of years that when something is powerful, you also need to take responsibility for that. So I think a couple of years ago, Microsoft started to think a lot on this topic, and that was to some extent also new for us. What does it mean when it comes to ethics and AI? And I think a couple of years later, we have all of this kind of a way that you can think about it. So you have these fairness principles, you have these privacy principles, transparency principles, etc. I think these are tools to help you think about ethics, because it means you can think on one thing, one topic at a time. So from a Microsoft perspective, a couple of years ago, we decided to kind of reorganize and create a couple of different groups to kind of control of how we deal with ethics in the company. So basically we founded 3 different organizations. It's something called the Ather Committee, which is kind of the think tank in the company. We have the Office of the Responsible AI, which is then, as it sounds, it's responsible for kind of pushing out the principles and guidelines, etc., in the organization. And we have an organization that is more focused on the engineering side. So if you're an engineer and you are a developer, how do you actually use tools, etc., to incorporate the principle and guidelines that's necessary for you, etc. So I think what we have done is basically taking those 3 organizations, making them work together. So we both have the thinking on it, We have the execution tools to kind of bring it out broader inside the company, and we have a couple of then guidelines for the engineers as well to actually know what are the guidelines when you go into code, basically.
Great. Yeah, I think that's very interesting to hear from your perspective as a large player in this field. Looking at you, Recorded Future, and Fredrik, as a developer, how do you, I think you shared quite a bit on this before, but would you mind expanding a bit on how you approach this landscape and what do you see is missing today?
Yeah, as you mentioned, it's it's quite a landscape, and it's still it's not the solved field, so to say, and there's a lot of what we can do. But what I think is mainly missing today is that we have these upcoming EU regulations, we have the upcoming ISO standard, but as a developer, I find it quite difficult to how to interpret these quite high level guidelines, regulations, and actually apply them to my work. So like, how do I go from high level to low level in the ethical guidelines? And another thing that I believe is quite important is that we must be able to, in some way, benchmark our data sets and our models against each other, because if we can't measure, so to say, the ethical performance of our models and data sets, we don't know then we can't improve them. So I think that the EU regulations and standards that are coming up it's a great start. It's great that it's happening, but I feel that what's missing is the connection between the high-level explanations and so to say, the connection to the low levels when we are actually working directly with the data and directly with models.
Yeah, I can understand that. Evelina, would you agree from your perspective at Paltarion?
Yeah, and I mean, there are many ethical considerations, and just taking a step back, I mean, what is ethically correct? What is morally correct? What are our values? There might be different views on that. However, I mean, if we look globally on all these policies and frameworks around ethics, I mean, we seem to have similar views on what we want. We want the algorithms to be fair and not to discriminate, to be secure and robust, etc. But I like to see ethics in three types of levels. Like the first level is, for what purposes do you want your AI system to work, or for what purposes? Because if it's a bad purpose, then we always will think that this is not ethically good. But if it's a good cause, if we agree on that, then you can move on to the next level and look into, for example, the guidelines from the EU Commission on how to build an ethically good algorithm. And the third level, I think, is the impact on society. We have many questions there, like what will it do to our jobs, for example? And some people also talk about like robot rights. But going back to what we do at Paltarion, I mean, if we just take the first level, like the purpose, we do have internal guidelines, ethical guidelines on which companies, sectors, etc. we work with. We also have training processes in place. We have an ethics committee, which goes from the board up to the code builders. And also we do some research, which I'm super proud of. Well, as you know, when it comes to transparency, we have the black box problem. When it comes to the most advanced machine learning models, we know what data that goes in. We know that something magic happens inside and we get an output, but we're not super clear to provide an explanation when it comes to what happened on the inside. And this is super important if we, for example, talk about the regulatory sectors, like banks, for example, and loan applications. You want to understand why this model came to its conclusion.
Yeah, I think this is really interesting. And also, as you say, taking a step back from the policy guidelines landscape and actually looking at what questions we need to ask ourselves to even start a project or to start building an algorithm. So in order to avoid that tick boxing exercise of fulfilling the requirements of the checklist and the policy and actually looking at what questions we need to start with, where would we start? Daniel?
So what questions do we need to ask ourselves? So, well, there are a lot of questions, of course, but we tried to, from the AI perspective, we worked on doing an inquiry to understand what questions does the general audience ask themselves, or when it comes to AI. It was kind of a big investigation, but one of the questions that we did ask at that point in time was 1,000 people. We asked them the question, how do you feel about the future of AI? So do you feel comfortable if you think about a future with much more algorithms making decisions for you? And we did it like this. So we had 1,000 people, and we took 500 people who got this question first. And then we had 500 people got this question last. So the last people basically had the opportunity to go through the inquiry and the questions, and they had the opportunity to think about AI and the problems that. So in general, I think people, the more you learn about the topic, the more comfortable you get with it. Like the pandemic, people was extremely afraid in the beginning. Now they had learned to live with it. And what we saw was that the persons that got the question first, 1/3 of those people felt that they were uncomfortable actually with the future. And after they went through the investigation, we saw half of the people. So we saw an increase in kind of the people's worries about AI. And I think the reason for that is that people doesn't necessarily realize the challenges with AI. And when they start to think about them, they see that this is complex matter. There are no easy answers. And when there's no easy answers, people get a little bit afraid. So I think with that guidance, my recommendation would be to talk much more about AI and trying to get used on the problems and start feeling comfortable with both the problems and the possible solutions, because there are many possible solutions to some of the problems that AI is also creating.
I think you're raising something very interesting here. So both that we need to talk more about AI and that we need to talk more about ethics during the process as well. So that it's not just something that comes in at one point of the process, but actually stays with you during the conversation. I think, Fredrik, would you share a bit about how this works for you when you're sitting down developing all the different algorithms? Do you feel that you have the conversation about ethics throughout the process, as you were mentioning earlier, or is it easy to get into the sort of finish the ethics part and then move on to the rest?
Yeah, I think it's very easy to get stuck in the last part that you mentioned, like do just the ethics part at the end and not see it as a natural and integral part of all your projects. But I think the main thing that we can do to actually start working more actively with ethics is to actually start allocating time for it within our projects. So that we as developers don't just see it as another thing to do. So it's not something that's just piled on top of all the other tasks that we already have, but it's a natural part of each project to have these regular meetings to discuss ethics and also do the ethical evaluation of the project and the phases that we are in. And as Johan mentioned in our presentation, that large parts of working with AI ethics can be considered as, already like best practices to do during development. But I think the main part is starting to like actually allocating time and seeing the ethical work as a natural and very integral part of all your projects.
And discuss the sort of implementation, but also the big questions, I'm guessing, in terms of what do we consider fair in this particular context. I think that sounds great. Is there any final comments from you, Evelyn? I know that you've been working a lot, very hands-on with different projects, but also in terms of the legal requirements and combining the policy landscape with the...
Yeah, I mean, I think it's a great input, and I definitely agree with what has been said. And I think, Fredrik, what you mentioned before around perspectives are key. But when it comes to ethics and developers, I mean, this is not only the responsibility of developers, it's for everyone in the organization. And I think one thing to think about is that on a daily basis, you might not feel that you are faced with moral dilemmas. But this can happen even though you're not fully aware of it. Even the simplest model can cause ethical dilemmas, basically depending on the context it's used.
Great, thank you very much to all three of you for joining us for this conversation today. I believe that we will talk a lot more about AI ethics moving forward as well. So it's really great to spend some time with us today during AI Sweden Partner Days too. And I can see that, Johanna, you're back here with us.
I'm back.
Yes.
Yes. And we're moving on to the last point of today. That is to talk about the roadmap for applied AI in Sweden. So today we talked about decentralized AI, we talked about language technology, and now we talked about ethics and applying ethics. And now, Daniel, you will share your thoughts on the roadmap for applied AI in Sweden and where we're going from here. So please introduce yourself and you can share your screen.
Absolutely. Hi, everyone. Nice to see you all. I'm going to share my presentation and hope it comes up. And first of all, just say that we've been talking about AI and different aspects from applied AI for 3 days now. So this has made my job pretty easy, basically. A lot of the stuff we've been talking about are really, really central points in how we think a roadmap for applied AI should look like in Sweden. But let's start with just setting the scene a bit. What do we want with applied AI in Sweden? Do we want to get better at developing methods for applying AI and being best in the world for that? Absolutely. But we also believe that we need to really accelerate the use of AI throughout society, really build up responsible, but really, really ubiquitous use of AI to realize the potential of AI as soon as possible, basically. So in that, let's make a few reflections on basically where we are and some of the challenges we stand in front of if we want to do that. So, of course, we have all now for the last 10 or 15 years basically been living through one of the AI revolutions. We can do so much more now with machine learning and data, and we can really start learning at scale. We do not have to put in as much manual work sometimes to actually encode knowledge, features, and things like that. We can learn at scale. We can attack different modalities such as vision and recently on a really, really large scale, natural language and things like that. But how do we operationalize this? How do we actually get this current AI revolution out everywhere in society? And of course, there are lots of examples of actual use of these things, but we need to get them out to broader scale. And how basically do we scale learning at scale? We face a similar problem to when we used to work with a lot of manual labor when we constructed not only expert systems, but also machine learning systems and so on, in that it took a lot of manual labor and time. Now, we also put in a lot of work sometimes on trying to aggregate the necessary data, the real data, finding the benchmarks, finding basically settings for these models to work. So how do we scale that? And some of what we're doing right now with an AI, I really do believe we can talk about just as basically go to real world deployment. And this is not just about machine learning. This is about optimization, scheduling, planning. A lot of technologies have developed a lot during the years to the stage where they're actually very mature to put in real world deployment. It comes with lots of challenges, but we can start to use them and build them. Then we also stand in front of the fact that we need to expand the scope and applicability of AI. A lot of these methods are very good. We know their potential, but they're not working everywhere where they need to work yet. They're not necessarily working on embedded systems in integrity sensitive systems like hospitals and stuff like that, in distributed systems like across cars or across countries with different regulations and stuff like that. So we need to expand the scope of where these AI methods can live. And of course, we also have this trend of actually building broader cognitive systems. We need to actually take a step further from the basically pattern recognition, mainly pattern recognition systems that we tend to work with today, to something with a more solid understanding and possibility to reason about the real world. But here in applied AI, we focus on the first two, basically. And bear with me, this is not a perfect analogy, but I would still like to bring it up and see if it sort of works. So a lot of the stuff that we build within research and things like that now are actually super performant language models, vision models, and so on and so on and so on. But it's actually sometimes systems that only can work within certain parameters. They only perform incredibly well with incredibly sophisticated technologies under specific circumstances. They're a little bit like the racing cars of the machine learning world. And what we typically need is something a lot more boring. We need to not only be able to build more robust, in this case, as an analogy, cars and transport and things like that, but actually build systems that churn these things out to a very large degree. But finally, and I think we should bear this with us when we're talking about applied AI in Sweden as well. Of course, as technologists and so on, we tend to think about building these let's call them systems or products or something like that. But for society, we need to think in terms of, well, cars are not necessarily the issue here. It's the whole transportation system. So how do we actually want to transport people and goods? And do we need to transport people and goods in the same way in the future? And we need that high level perspective as well. Difficult to keep in mind, but we need that high level perspective. So then when we build these more robust systems and so on, of course, we're going to realize that, yes, building AI systems is relatively can be relatively complicated in terms of infrastructure and things like that. And they really need to work in a different way sometimes. This is, of course, just the picture from SVT from, I think, earlier this year. It's just an example of these things go wrong, right? Of course, it says smittspridning av covid-19 because the automatic model to transcribe this text hasn't necessarily yet learned what COVID-19 is. But still, these are things we need to manage when we move out from just papers and demos and things like that to continuously running these systems in the real world. And here are some of the issues that I could spend a huge time talking about, but what matters in the real world? Well, basically what matters in the real world is, first of all, what matters all the time, generalization performance. But I'm talking in a broader perspective here. We need to generalize not only to new data sets and things like that, but new situations that might actually be a little bit different. And we cannot necessarily always measure just on prediction, classification, or something like that performance. We need to bring in other aspects as well. I think it was interestingly put in the earlier panel and so on. We need sort of benchmarks to evaluate also for example, ethical issues, stuff like that, that we need to bring into real work models. But robustness is a key issue. Of course, it's part of generalization, but robustness is a key issue. When you actually work with things in real life, we really do want them to work. And performance is often, if it's good enough, but we want it to be robust towards changes and strange situations and things like that. But it's also an issue about actually building models quickly and moving a little bit away in a mindset from building super performance stuff that takes a lot of tweaking to set up to, let's call it, approaches that are robust in how we design them so that they can actually manage different situations. That's a matter of productivity, basically. But these are fundamental issues that we shouldn't spend too much time on right now, perhaps. But what do we think is necessary then to operationalize the current AI revolution? Well, we want to define a number of specific areas where we can work together in Sweden. We have scattered resources. We don't have resources collected in just one place in Sweden for us to really take a place necessarily on the world stage, but we really do have the opportunity to not only solve important problems for Swedish society, but also be world leaders potentially in not all of AI, but at least some of areas within AI. So we are working with strategic programs and areas that can solve some of these key issues for accelerating operationalizing AI in Sweden. Of course, then we want to provide platforms where we can come together and work with these things. So they need to be problems that are common for many sectors, actors, people, and so on. And they can actually contribute to putting Sweden on the map in collaboration with the rest of the world, of course. And we have set it up basically around these strategic research and innovation areas, but also when we're talking about the broader societal impact of AI, looking at some major impact initiatives. We'll get back to those soon. Which are these areas? Well, we focus on some of these basic challenges that we've discussed so far during these last 3 days. Sometimes data just don't want to be free. It's got sensitive, integrity sensitive data within them. We can't spread them. They're stuck in different jurisdictions. They're stuck on devices, and so on and so on. We need to look at alternative approaches such as decentralized AI, federated learning, and so on to actually make sure that we can get this out. We know, of course, as we discussed earlier, that we need to put AI to use in many different and new places, and we need to be able to actually cooperate with AI in a new way when we put it to practice, both humans, but also control systems and things like that. And there are tons of both practical and more fundamental issues here. And also, finally, AI is more than just algorithms. We've spent some time with actually looking at AI transformation and what that means. We've talked about ethics and AI, and I will also like to bring up systems and software, basically. This kind of basically building components that we can reuse again and again to actually accelerate the use of AI. And these are the ones that we've been working on. Most of you know them already. I'm just going to mention the ones that have been talked about today mostly. Decentralized AI. We have started working here. We know that, for example, for healthcare, for telecom, for automotive, for parts of industrial production and so on, we're going to have to look into these issues, and it's super important for Sweden. We are looking at language technologies because so much of the data that we actually need to access is in terms of text. We know that to actually interact with these systems, we need to better language models and ways of actually interacting naturally the way we humans do with these systems. And I'm also going to mention one final one that is a strategic area in itself. And we've also had a day on AI transformation recently, a couple of days actually. How do we transform organizations? Super important, but how to do that is also a strategic area in itself. And all of these areas and programs, we tend to run now as one program where we together answer central issues on how to do these things, but connect them to a lab, a place where we can actually try these things out. So if we look at our decentralized AI program, we have the Edge Lab, where you can come and try out solutions for real, on real equipment, and actually see what happens. When we have these programs, when we have these labs, we want, of course, to move to real applications and impact. And one of the ways is actually spreading the results in a super efficient way. And then we're not talking about just papers and reports and so on. And we really want to push this for Sweden, that we want also to basically produce material to help guide people in a very simple way. Best practices, condensated documentation on state-of-the-art methods and the best way to use them. These kinds of shared platforms for experimentation. We want to, of course, share as much as possible on systems, prototype development, and so on, so that we don't just stay at proof of concepts all the time. And we need to, if we cannot share data, perhaps we can share models, we need to share benchmarks, and the benchmarks need to get wider. But all of these things we can build, share, and continue to build up on, and that will really accelerate the AI use. Finally, let me just get back to a final area where we can more specifically, and also from a more of a societal point of view, drive AI in Sweden. And that is through major impact initiatives. And of course, we're looking at healthcare, which is such a central issue for Sweden. And of course, if you look at the complete systems and so on, we can do a whole lot. But in the end, it also comes down to how does society want to drive and provide healthcare in Sweden? So this is a more complex issue. It's a perfect type of area to drive AI development, but its scope is much bigger than just technology. The same goes for climate change prevention, media, AI, democracy, mobility, and logistics. So yes, we do believe that Sweden can be a pioneer in applied AI. We really need to work to get there, though. And we really need to work on not only technologies and all these labs and great proof of concepts, but to get stuff out there and actually make a change in society. And I think I will stop here.
Thank you so much, Daniel. And maybe you can stay for a few more minutes and help us wrap up this partner days. So I think I have a first question. We started this day by talking about decentralized AI. And when do you see that we actually can say that we have applied decentralized AI at scale? When do you think that will happen?
Yeah, I mean, it's going to creep in, right? So hopefully we're going to be able to point to a really large scale system soon that actually utilizes these things. And I don't think we're too far away, but it might be completely, let's say, invisible. Some of these things are creeping into, for example, telecom systems. They're working on smaller scale and so on within, for example, automotive, but it's not things that we think of as a huge impact on us, people, and so on. So I think we're perhaps going to see the real impact when we realize that we have better diagnostics systems that are trained on data from China, Sweden, Africa, whatever, and actually collaborating to build a better medical diagnosis for us, and so on. And then we're really gonna see the value in our daily life, or at least in terms of healthcare, hopefully perhaps not in our daily life, but when we really need it.
Yeah.
So what would you want partners to do?
I think I would basically like partners to really engage, but because what we can see is that there are so many issues that are really common for a lot of partners. And perhaps the thought process hasn't gone as far as realizing that, yeah, we need decentralized AI, but there might be an interest. Then talk to us and see where it sort of fits, because we have seen again and again and again that partners come in, start talking about these issues and realize, yeah, we really need to look at this, and we can do it together with other people. So engagement is really, really what we want, right?
I believe that's really right. And we've seen it throughout these days as well. It's legal issues, it's technical issues, and I think we can just collaboration, that's what we always push, right? Is one way forward that we believe in. Yep. So we also really want to encourage partners to contact us and also find other partners to work with. That's the whole purpose of it. So with that, we're heading 10:45. And we want to wrap up these days. And I think it's been really great insights and presentations that we've seen. Very good to hear your future perspective, Daniel, of this. Thank you so much, Johanna.
Yeah, thank you, Ebba.
And thanks to all the people and partners who have presented throughout these days and put all the efforts in to make us all be better at using AI. So thank you so much. We'll see you soon, and please reach out by email or any other way and make contact. All right, thank you so much.